Okay, so today, quick little talk, only 20, 30 minutes, but want to try and cover a lot of ground here. So first off, I want to go over what is QRadar exactly, just to give you a bit more background. Then I want to talk about EBA, so kind of walk you through a little scenario of like detecting an insider threat. I want to talk about our machine learning pipeline, and then about some of the future of our machine learning and where we're going, and then some of the kind of challenges and best practices we found on our journey so far over the last couple of years. So first off, what is QRadar? So QRadar was the pride and joy of Q1 Labs, which was a small company that started and was founded in New Brunswick here, like right out of UNB actually. And it was acquired by IBM in 2011 for a couple $100 million. Now QRadar is like, it's called a SIEM. That's kind of what the name is in the space. And it's security, information, and event management. That sounds really fancy, but really what it does is just, it's a tool to let you see everything going on in your network in one spot. It doesn't actually stop attacks or block accounts or self-destruct computers or anything like that. It's just a visibility and monitoring tool. And what it does is collects data from thousands of devices and endpoints and applications in your network and puts it all in one spot. So we get all this information and we aggregate it into individual like alerts that an analyst can actually go look at. So we've got so much data coming in, we need to condense it down to a reasonable amount that real people can actually look at and take actions on. If you ever used QRadar or looked at it, like this is what it looks like. It's kind of a very robust tool where you're just going to see a lot of data flying by, and you can like search and filter and look at information here. So it's a very like data rich and data centric tool. Now, QRadar operates at a massive scale. So when we're using QRadar, like most customers aren't just looking at like one computer or one server. A lot of customers are looking at like thousands or hundreds of thousands of systems. So there might be like thousands of databases and like every computer in like their whole network and every application. Like if you imagine just for UNB, even like how many computers and how many people that is. And we have customers like 10 times that size. Now this volume of data is very large. Like the way we rate this is by how many events per second come into the system. And we have some clients that bring in over millions of events, like over 1 million events per second, which ends up being terabytes of data per day and just a huge, huge volume of data. Now, if you went back to QRadar, it would look like this basically, where you've got like, you could actually look at the data coming in live, but it's going to look like the Matrix almost with like the events and data kind of flying by here, where it's just too much data to actually do anything with. And that's where the whole idea of condensing it down into something more useful is a really important idea for the SIEM. So we have all this really rich data in QRadar. Like, how can we use this to detect insider threats? So our goal is like we'd build this UBA tool on top of QRadar, and we would use all this existing data in QRadar. So we have customers with like hundreds of thousands of data sources coming in. We have all these existing integrations with different other like security vendors and security devices and applications. So let's use all that. Let's leverage that. Customers spend a lot of time setting up their QRadar system. So they spend a lot of time defining things like what are their databases, what are their servers, what does their network look like. Let's use all that too. Like let's make it really easy to just use all the stuff they have in QRadar and look for these insider threats. Another big part of it is UBA is really a capability or part of the SIEM. It's kind of the evolution of it. There are some competitors in the UBA space, but they're all standalone products where you have to take the same data you're putting into your QRadar, but then also put it in this other tool. And this is really painful for teams because it's just more places you have to store and manage the data and leads to a lot of operational costs. So it's expensive to manage it in 2 places, and you're going to send the same data to 2 places. And a lot of the times you might have to pick and choose, like certain data you can only put in one spot, for example. So you lose visibility, which is not good. So this is like a little story I always like to walk through showing off UBA and what it does. It's called catching the bad guys. So we can pretend we have Joe Schmo, who's a longtime employee of a large financial company, and he might work at night doing data backups. He has a pretty boring job, And he's got a bunch of accounts that belong to him. So he might have like a SAM account on Active Directory, maybe some Linux accounts, email address, AWS account, and like there's IPs and devices associated with them. So if I'm a SOC analyst or like I use QRadar, I install UBA, like where is Joe Schmo right now? So this is what the EBA dashboard looks like. Like it's a pretty rich and colorful dashboard where we're going to have like lists of risky people and all this information. But the point is, like, Joe's not here right now. So Joe's not doing anything interesting. Like, he's not risky. So UBA is not going to tell you to go look at him. And we're not going to like open up any cases or incidents or anything for him. So let's say Joe's been having a hard time with his marriage lately. Like maybe he's having money problems and he thinks he can exfiltrate some data and sell it. So he works at night, no one else is around. So maybe he thinks he can kind of get away with this type of behavior. So first thing he does maybe is try and access some risky assets where he knows some useful information is, like where the treasure is. So maybe some customer lists or credit card numbers or so on. So UBA has some use cases around this. We would give him some risk for this, and it might have been with his SAM account. Next, maybe he SSHs onto this box where he found some good data, and he's on there executing like some SSH or Linux audit type events. And we've never seen this before from him. So we'll give him a bit more risk for this, and we'll give it for his Linux account. Lastly, like let's say he finally got what he wants, and now he wants to copy it to some remote server so he can actually like sell it. So here we have exfiltration. We have a really big file transfer from a local network to a remote one, and we'll give him a bunch more risk here. So the whole idea for UBA is like we want to know about all these different accounts that are all actually the same person and roll them up together, and then also roll up this risky behavior together. So now if I go back to UBA, like Joe's like the top risky person, we're going to make an incident or a case in QRadar for him to go look at. And we can actually open up his page and go look into a bunch more details about like who he is, where he lives, what's his department, who does he work with. We'll get like a rich timeline of what he's done. So things like what different use cases or machine learning alerts we got. And then we can even drill into specific ones to see what caused it to happen. So maybe here he triggered some use case about VPN access. We can click on this to drill in and see the actual raw data and payloads that caused it to fire. So really, really high level, that's what UBA does. Like two problems where we want to connect accounts together that Curator doesn't know about. And then we also want to measure risky behavior. So measuring this risky behavior, we use our rules engine analytics for, but this is where we also use machine learning to detect this bad behavior. So we do have some success stories from customers where like they've put UBA on and detected really interesting things. I don't want to go through all these, but some interesting ones are things like detecting red team exercises. So this is where like internally you might have like hackers you hire to just test your network. Like we've had some finance companies we work with where UBA was like the best tool for detecting that. And we have had some cases too where there was actual like breaches of data exfiltration for some TV shows, for example, and UBA was able to like pick out and show all the accounts and show what happened in that case. So these are all some kind of like cool success stories about things we've detected with UBA using our rules and policies, but also machine learning. So I wanted to talk a bit deeper now about the machine learning side of UBA. So the way UBA and machine learning works on QRadar is we use what's called the app framework on QRadar. I don't have time to get into all the details here today because it's only a quick talk, but what the app framework lets us do is write little apps that run in Docker containers and sit on top of QRadar and use all QRadar's data. So both UBA and machine learning run as an app like that in a Docker container. For machine learning, like the most important technologies are we use Spark and Spark MLlib, and we use Zookeeper for like scheduling and configuring everything. So those are like really the two main technologies. We do have like a machine learning pipeline set up for each of our analytics, and it's pretty simple, but it does have a few steps. So the way each analytic works is like it's on an interval, so like once an hour, for example. And what we'll do is first we'll ingest data from QRadar. So here we'll use QRadar's APIs with like a JDBC driver we made to load data from QRadar into Spark SQL. And then we'll store this as a data frame in like a Parquet file, which is kind of like partition JSON. After we've pulled the raw data, so this is like the real data and features from QRadar, next we'll actually perform our analytics. So here's where we'll like extract and make new features. We'll build and fit our model, and then we'll store and serialize our model. Lastly, we have scoring, and this is where we will do our predictions and then look for outliers and anomalies, and then generate alerts when we see bad stuff happening. So the first type of analytic we added to our machine learning was just simple time series anomaly detection. A lot of people like to joke it's just like the hello world of machine learning. And what this lets us do is just measure a feature in time, something, maybe a rate of change, a unique count, or new items. And we measure this feature and then compare it against like a known or learned pattern. So this slide here is just a really simple diagram of this where we'll have some feature we'll want to measure, and we'll come up with like a weekly model for it. So we'll take a month of data, for example, and then come up with what we think looks normal over a week for a person. So we can use this on a lot of different features. Like we can just use it on all of their network traffic to see when they're active during the day, for example. But we can also measure other things like how much data they download or upload during the day, and like any of the other kind of data we have inside of QRadar. So this is what it actually looks like in like the EBA app. The way we visualize the model is just like we'll show the model as learned behavior in blue, and then we'll show the actual data coming in as black, and then we'll show like little red dots where there's anomalies or outliers and where we'll generate risk for it. So we have a lot of out-of-the-box models we let people use. So these are kind of really general models that should work for most customers. We also let you define your own models, and it's more of a power user function. So we let you basically define any feature you want from QRadar, how to measure it, and then any filters you want to apply on it too. So some examples of this, like the powerful things you can do would be stuff like you can set up a model to measure how many S3 buckets each person connects to or talks to, or maybe how many emails each person sends on Office 365 a day, or how many unique Windows applications you use. So QRadar, like there's thousands of features in QRadar, and we can pick any kind of combination of them and then baseline them here. So I want to talk a little bit now about the future of our UBA and machine learning that we're working on. So I mentioned earlier, like QRadar has hundreds of device integrations, and like I would never have time to go through them all, but I can put them in 3 buckets here. So the 3 buckets that UBA really cares about are like access and authentication type logs. So these are things like people logging in and out of accounts, people signing in, badging in, and so on. The next general bucket or type of logs we care about is like network behavior. So these are what users are actually doing on the network. So stuff like proxy, VPN, firewall logs. And then the more advanced ones are like your endpoint and application logs. So these are like what people are actually doing on workstations, what people are doing in applications. So we have like these different types of data for UBA. And what we're working on now is coming up with ways to model each of these different types of behavior in general. And we're kind of calling these behavior models, where we want to look at behaviors of related groups of features. So for example, we might want to look at your network addresses, make a model around that, and then look for like outliers and anomalies. Maybe you want to look at like your browsing behavior, what you're doing on Windows, what you're doing on cloud, for example. So AWS, Azure, GCP. And our goal with this is like we want to extract a bunch of features and data from QRadar all at once because it's much more efficient and faster. And then we can kind of make these broad models. So here would be an example for network addresses. So like the question we're trying to answer here essentially is like, what are the normal network addresses for each person? So if I'm looking at user Matt, like what are the normal network addresses for Matt? So QRadar has like a bunch of fields we can extract, but for network addresses, some relevant ones might be like MAC addresses, IP addresses, and ports. So there's a bunch of different ways we can actually measure these fields. So we can measure like how much network traffic we have, and we can also measure the unique count, so how many of them we see. Now, there's a bunch of permutations of these too, because for each of these fields, it can be a source or destination, and then we can always apply filters to measure this for only specific types of data. So maybe I want to look at IP addresses, but only local ones, or I want to look at ports, but only for the proxy traffic, or only AWS, and so on. You can also use these fields or data to look up other information. So for example, you can take an IP address, but then go look up a country or look up a network name. So some examples of like network address features might be like how many unique local source IPs you have, or how many destination IP addresses, but only for external networks, or maybe how much traffic you have to Russia, or how many ports we see, but only local ones and in like a low range. So these are just a couple simple examples, but you can see even from just really 3 features, there's like thousands of permutations and other super features we can make. So our goal is like for example, we'd use all these features like the network ones to make a behavior model. And then we'd use outlier novelty detection algorithms on them to look for big changes in behavior. We're looking at a few different algorithms now, like isolation forest, local outlier factor, and a few others. Like we're doing a lot of testing now. That's kind of what one of the projects with CIC is about. And the goal here is like we'd compare each person against themselves. So say for Matt, I can learn like what Matt's normal network addresses are, and then look for kind of outliers. So if all of a sudden my behavior changes a lot, we can kind of make an anomaly on that and say, hey, we think Matt looks very different. And then we can also compare people against their peers. So we know like what department people are from, what their job title is, what their city is. We can use that to cluster people together and compare them. So say if I'm Matt, I'm from the office in Fredericton, I can look at the network behavior of all the people in Fredericton and then look for outliers and see if Matt looks like a normal person from Fredericton or if he's doing crazy stuff compared to everyone. We have a bunch of different visualization ideas we're floating around for this now too. This is always a challenge with like machine learning too, where we are looking at like tree-based outlier detection. So like we can use trees to visualize and explain why you're an outlier. And we're looking at like box plots and PCA and a few other algorithms too to kind of help explain why someone is an outlier, for example, if we're looking at like 20 features at once. So last, I just wanted to quickly talk about some challenges of machine learning and cybersecurity data. Our apps existed for a couple of years now, and we've had a lot of lessons learned the hard way, and I just wanted to kind of talk about a few of those. So one of the first challenges we always run into is around testing data. So like no customer really wants to share live or real data with anyone. There's GDPR and so many other regulations and policies that prevent this. So there's no way we're ever going to go talk to a client and they're just going to give us like a hard drive or a flash drive with a bunch of like real security data on it. And they're especially not going to share data like when they got hacked or an incident happened, which is like the perfect data that we would really like. So some of the ways we've worked around this is we do have tools and automation to generate test data. So these aren't perfect, obviously, but we've spent a lot of time to make these tools, and they've helped us at least generate fake data that we can use with our pipeline. So we'll use the tool to generate data, and then we can also add like outliers and anomalies manually or in scripted ways by like adding noise and adding randomness. So we can't get like the exact real data from customers, but we can get some insights from them at least, and we try and do this a lot. So we can get stuff like the distribution and shape of data from customers. So maybe we can't get like the real IP addresses or what websites they went to, but maybe we can get like the distribution and see if it's like a normal distribution or if it's bimodal or what it is. And maybe there's other metrics and metadata we can get from them too, where it's not like descriptive or PI or anything, but it's things they can share. And maybe in some cases you can get obfuscated data samples from customers too. Another option we've done before as well is a lot of customers you can't take data out, but you can actually like go visit a customer and run analytics or models where the data is like on site. So this is another thing we've done in the past too, where we'll have scripts and tools to go visit a customer and then like run the models there and actually try things live, but not be able to bring anything back. Another big challenge is a lack of labeled data. So labeling just means like classified data. So for example, if data is malicious or not, if it's an outlier or not. And like a lot of times we just don't have that, and it's not really feasible to manually label this data because there's so much coming in, like terabytes per day. So some solutions we've had for this, the biggest one probably is just focusing on algorithms that don't need labels. So we do a lot of outlier and anomaly detection that don't need any labeled data, as well as clustering. Another way of getting around this is by using other interesting fields to label data as bad. So maybe we see like an antivirus event, we can use that and then say, okay, we saw a virus on this computer, maybe for an hour before and an hour after, like we'll label any of that data as bad, for example. Another similar idea is maybe like we see a phishing email. So we have Susie, and Susie clicks on a phishing email. We know that any traffic from Susie, like before and after, could potentially be bad, and we could label it bad. There's also other types of incidents and alerts we could use to do this labeling. So maybe if like another security vendor sees some type of alert, we can use that and then use that to label like bad data. It's always tricky here though, like when we're trying to classify data. So for example, if we looked at doing this first one, like antivirus event detected, if we use this and kept labeling every time we see antivirus events bad, like we're not really going to teach the model to detect bad behavior. We're really just teaching it to detect antivirus behavior. So we kind of have to keep that in mind when we train models and not overfit them too. Another big challenge we've had is just around performance and scalability. So like QRadar is a very, very big system, and a lot of times we have limited memory, CPU, and disk resources. And we also have limited time. So there's only so much time in like a day or an hour where we can like load data, fit a model, and do predictions and scoring. So it's a huge, huge problem and like a big thing my team is focused on. Also, you can kill QRadar on these SIEM products by asking for too much data. If you ask for like a year's worth of data, you can really hurt these systems. It can take a long time and just eat up all the resources on it. So some ways we've worked around this is by getting as much data at once as possible. So we'll try and do one big query to get all the features at once, for example, and then reuse that for a bunch of different models. We'll also try and extract new features and combinations from existing fields. So the whole idea of kind of doing more with less. Another thing we have to focus on a lot too is trying to identify high value, low cost features, where the cost is maybe like how complex or how much space the feature would take. So maybe instead of IP addresses, for example, because there's so many, we might use like a network name instead. Or maybe instead of just pure port, maybe we round the port, or we take like port ranges instead of just specific ports. And another thing here is like we've had a lot of focus on data engineering instead of data science, because we found that to be kind of our bottleneck has been like the data engineering side. A few other kind of general challenges that we don't really have solutions for yet, but I think they're kind of common across the industry. So one big thing we always find we're lacking is subject matter expertise. So to be successful, like we have to know security, we have to know networking, and then data science and engineering. So that's a lot of different kind of topics someone has to know. We have to figure out what fields or features are important, but also low cost. So it's trying to do the balancing act of finding really useful, rich features that don't take too many resources, and that's challenging. And that kind of comes back to being resourceful here. So like maybe using fewer features, but finding novel combinations of them. And then just in general, we found this subject matter expertise much more important than data science knowledge. We found it's pretty trivial to like learn machine learning algorithms and use scikit-learn and so on, but it's really, really hard to understand security data. So we've been working with security experts a lot more and focusing on this part of our product a lot. Another big challenge we've had is just disparate customer needs. Like QRadar has thousands of customers, and like there's so many different types of companies out there. Like the needs of a university where you've got students watching like YouTube videos and downloading torrents all day is very different from a bank, which might be like a super locked down secure network using like really old mainframes and Windows boxes, compared to like manufacturing companies and healthcare companies and so on. So all these customers very different needs, and it's hard to do one size fits all. Another challenge we have too is around visualizations. So say we find something bad, like we detect an anomaly or an outlier, we predict something bad. We have to show and explain why it's bad to humans. And this can be really challenging sometimes. Like imagine we have some model with like 20 features or 50 features,